today's lesson we're going to do 2 extra examples on Theorem 2. It's on page 20 onwards. In the first example, I say that in the figure TS is perpendicular to PX and RQ is perpendicular on PT. Now you have to prove that this green triangle is similar to the large yellow triangle. I start with in triangle this and triangle that. I did. So, if we can prove 2 angles that are equal in both triangles, the third angle will automatically be the same, and therefore you can say that these 2 triangles are similar. So angle P in the green triangle equals angle P in the yellow one. It's a common angle. Angle R1 equals to angle PST, which is 90 degrees. That's given. Therefore, the green triangle is similar to the yellow triangle. Now, if you write the names of the triangles here, you must make sure that the first alphabet letter, which represents angle P in green, is equal to angle P in yellow. And angle R in green equals to angle S in yellow. And angle Q in green equals to angle T in yellow. Do you follow? Yes? Your reason is angle, 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 or equiangular triangles. Then for question B, you have to prove that RQ to PQ equals ST to PT. Okay, now before I can carry on, I want to show you something, so you have to look at me. You go to the question. They want RQ. Then you look for RQ in the name of your triangles, and there I see is RQ. So I draw a little bow. Then you look for PQ. PQ is here. Then you look for ST. ST is here, and PT is there. And if you have the same pattern on both sides of the similarity, you know that you are correct, and now you can do the proportions. So you say RQ, which is the small one, over ST, which is the small one, equals PQ, the big dome, over PT, the big dome. Why can I say that? Because I have equiangular triangles or similar triangles.
That like a shorter way to say it?
Yes.
And so is there always a pattern?
There should be a pattern. If you don't have a pattern, then you must look for equal sides or equal angles or whatever to change your pattern so that it looks the same. But it must look the same before you can carry on. Right, now they want RQ to PQ. So RQ is on the correct place, and they want ST to PT. So PT is on the right place. But these two must be swapped. So I'm gonna show you the long way. You can combine steps. I first multiplied with ST, and then I multiplied with PT, then I divided with PQ, and I divided with PT, and then you just write your proportion in terms of RQ to PQ, etc. Are there any questions with number B? Okay, we're still busy. So for number C, I must get PR times PT equals PQ times PS. So I'm going to write my similarity of the two triangles again, just so that I can make my little domes. PR is this one, PT is that one, PQ is this one, and PS is that one. I have the same pattern, so now you can divide. PR, the small dome, divided by the small dome, equals the large dome, divided by the large dome, and then you just cross multiply. And remember your reason.
And then always follow this pattern.
You must always follow the pattern.
No, I'm saying that these questions are always following this exact pattern. We're going to have to draw it again.
Okay, this is just a trick. It's not part of your question. Okay, so this is just a trick, and then you'll see it works out all the time. Okay, the next example, example 3 on page 21. Okay, let me just write these out first. I say that in the figure, CD is perpendicular to AB and AF is perpendicular to BC. Prove that CE over CF equals CB over CD. Now in this picture you have three triangles. So which ones do you need to prove similar first? You quickly go to these parts that are actually side lengths of triangles. So you look for CE, it's this one, and CF is this one, CB is this one, and CD is that one. So which triangles do you think are we going to work with? The pink one and the green one. Okay, I'm just going to write this out again. So now you know that you can prove the pink and the green one similar. By saying that angle C equals angle C, it's a common angle. Angle F2 in the green one equals to angle D1 in the pink one. and both are 90 degrees, that's given. So if two angles are equal to two angles in another triangle, the third one will be automatically equal. Therefore, you can say that the green triangle is similar to the pink triangle, angle, 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 or equal angled triangles. Right, now you look at what they ask you. CE, so I look for CE, it's this bottom one, and CF is that one, CB is this bottom one, and CD is that top one. The patterns are the same, so I can do the proportions. CE, the big one on the left, divided by the big one on the right, equals the small one on the left divided by the small one on the right. Because I have equi-angled triangles. Now you look at what was asked. They want CE over CF. So CE is on the right place, and CB over CD, so CD is on the right place. Therefore, I just need to move those two. You can do it in separate steps or in two or one step, but you have to show how you get it. Okay, now for number B. First you need to look which triangles we're going to work with. So we have AE, and again AE because it's AE squared. Then you have CE and DE. Okay. I see a red flag because there are two of the same that I need. But can I change this one with something else?
Yes.
Yeah, these two are equal, so I can change that one to this one, and then you can see you need the yellow triangle and the green triangle. These are tricks that I show you. How to get to which triangles you first need to prove similar, and then you do the proportions. Okay, so let's start with, I'm going to use triangle green and triangle yellow. So E1 in the green equals to E2 in the yellow. They are vertically opposite. F2 in the green one equals to D2 in the yellow one, which is 90 degrees. It was given. Therefore, the green triangle is similar to the yellow triangle. You can either say angle, 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 or equi-angled triangles. So before you can do a proportion, you need to do similarity first. And with the similarity, you look at what they ask you, AE twice. Okay, there's an AE twice. Then CE, there's a CE, and DE, there's a DE. Is the pattern the same? No. But we saw that one AE can be changed to EF. So you look for an EF and you take away one AE. Now the patterns are the same. So now you can do the dividing. CE, the first dome, over AE, the first dome on the right, equals EF, the second dome, divided by the second dome on the right. But that's not what they asked. They want two AEs. So you have to say that AE equals FE, therefore I can change that EF or FE to an AE. And then you just cross multiply and you get your answer. Are there any questions with this example? Okay, we're still busy. Your homework for tomorrow is number 2 and 3 of exercise 3. So let's quickly go to number 1 to mark it.